Hello again, it's Mr. Pete, your YouTube shop teacher, and you are watching tips number 815, which is part 2 of a two-part video. I hope that you watched part 1, and I'll put the link for that in the description if you haven't seen it, but this is the video where I'm going to finish off the offset attachment for the milling attachment. So, let's begin. To recap here real quickly, what I'm doing is this is the milling attachment and we're at a 9-inch South Bend lathe, and notice here as I back the cross slide out, that is the limit of my travel. I cannot mill the whole piece. So if I take this off real quickly, you can see that this is what the milling attachment looks like. That's just a wooden mock-up that moves the attachment back 1.5 inches in a position like that so that I can mill the entire piece. It also raises the attachment about 1/2 inch, which may or may not be a benefit. So the attachment will go right on this plug like this, and in part 1 I made this dovetail plug. I hope you watched that. There's some interesting operations there if you have not. So this will be used today in this video, and I've already prepared a piece of 1/2 inch thick stock. That hole was there. It has nothing to do with the project. And I have milled it down to the basic dimensions, which are not very critical, so it's going to have 2 holes in it. That's what we're going to do today. We're just going to drill and bore 2 holes and fasten the plug into it. Now there's a lot of pictures at the end of the video. Make sure that you look at those. Okay, let's go down to Studio B and do some chip removal. See you in a minute. In review, the material, the 1/2 inch thick cold roll steel, is 3 3/8 wide and 4.5 long. Now I'll put some bluing on this and we'll lay out the 2 holes. So the only layout really is the center of the 2 holes. And remember that the 2 holes are exactly 1 1/2 inches apart. And I got that dimension out of the South Bend catalog. There was no blueprint, there will be no blueprint to this. It's so simple. Okay, looking at our living blueprint here, the center line of the piece is 1.700. This dimension is not critical. And the first hole is 1 inch down from the top. And of course the center to center distance is 1.5 inches. One inch down and 2.5 inches, and I know this is only semi-accurate, but in fact in the end I'll be using the digital readout on the milling machine. So that completes the layout. Let's step over to the Bridgeport. Okay, let me put the workpiece in the vise. Notice that I'm setting it on 2 1-inch parallels, and I told you many times there's no greater luxury than plenty of clean rags and plenty of parallels. So everything's clean, including the work, no burrs on it, and in it goes such that the drills will not hit the vise or the parallels. So I'll tighten that up. And I'm going to use a wiggler to locate the first hole because, again, I know I laid it out accurately, but it's kind of not that critical, just so I'm about in the middle. And the distance between the 2 holes, 1.5 inches, is what's really important, but yet it's not. It could be 1 3/8, I suppose. So as long as the 2 holes do not interfere with each other, 1 7/16, I should have said. All right, let me locate this mark with the wiggler. Okay, I'm right on, and I will lock the table in both directions. I'm going to zero out the digital readout, which you cannot see in your view. Now I will pilot drill both holes, 1/4 inch stubby starter drill. These are samples that I drilled with a hole saw the other day, or I should say I sawed them with a hole saw. This is 1¼ inch, this is 1 3/8, but the 1 3/8 really is too sloppy because I would like a real tight fit there. Not a press fit, but a real tight fit. So I will use 1¼ inch, which is this Starrett right here. It's not the newest, it's not the sharpest, and each hole takes quite a bit of time. That's a 1/4 inch pilot there, so that's why I drilled those holes 1/4 inch. And this has to be run at an extremely slow speed, 300 or 400 RPM. You'll burn them up if you don't. Do you mind terribly if I digress for a moment? This is my drill bit shelf right alongside the Bridgeport, and on this shelf are 10, 20, it could be 50,000 drill bits because some are so tiny. But among this entire selection, and there's lots more out in the garage and other places, I do not have much at all in the way of larger drill bits, and because I need to drill a 1 1/4 inch hole at least, and I don't have drills and reamers that big. I was kind of surprised. And granted, I do not drill that many big holes, obviously, but here is a set of silver Demings, and they only go up to about 1 inch. And then I do not really like to use taper shank bits because they require you to lower the table so far. You just need a lot of working room. And I don't go quite that big with these either. So I'm going to use a hole saw. And believe me, I've got a lot of hole saws. As I said, this will be real slow going, and you need plenty of oil. And as you get a little bit deeper in your work with a hole saw, you need to keep retracting so you can clear the chips. Also with a brush, get the chips out of the teeth. I'm only about halfway through and it's just going so slow. I switched to another hole saw. I do not know if it's any better. Wow, that took more than 5 minutes. This one is a little bit better than the other one, but they're both old and worn out just like me, and they're missing teeth just like me. Let me move over to the other one. You know, you can tell when one of these is dull when the swarf is more like powder or dust than what it is curly chips. Wow, I went through really fast with that one. I don't know what the difference was. And it's a lot smoother hole too. Not that it matters. Hot, hot. And there we go. Now I really do not know if this is faster. It would be definitely faster if I had sharp new hole saws, because the amount of chips produced here as opposed to the way you would do it with a regular drill bits is significant. So, or insignificant. I don't know. Anyway, that's how I did it. You can do it any way you want. Okay, now comes the boring part of this video. I have mounted the Criterion boring head in here with a boring bar, and I've already set it such that I'll be taking a scratch cut. And my final dimension for both of the holes is 1.375, although I might make this one just a thousandth or two smaller so that I could actually have a press fit of the dovetail in there. That would be great if I can make that happen. Otherwise, that's going to be held in with a pin. And we want a slip fit here for the attachment itself. Okay, let's get started. I've taken several passes off camera of both holes, and I'm about 25 thousandths from my target size. Now, do you remember when I made this little device here a year or two ago that clamps onto a boring head and has an indicator that can be attached? This little dial here where I have the Allen wrench is preposterously small and hard to read. And I'm at the end of the adjustment there. I might need to move the boring bar. So anyway, watch the, I'm going to take off 10 thousandths. Now, a fella has to make sure he remembers to remove this, which is kind of time consuming. You don't want to start the machine up with that indicator on there. All right, let's go. Okay, I'm at 1,371, almost there. I took one more pass and I think I'm right on, so let's see if this compound fits. I dropped the table a little bit so I've got clearance here, barely. And yes, it goes in just nice, no slop. So that hole is done. I took one more pass in this hole and I only went halfway down, and the plug now fits barely down to that little shoulder that I just made. So I'm going to press fit it from there, but I in fact will probably heat this piece up and this should drop right in place. I'm done here. I've got some holes to drill yet though. That really went fast and wasn't as boring as I thought it would be. As you probably know, on South Bend lathes there are hardened pegs with that 60-degree angle on them that fit into that dovetail. Well, this attachment here requires, at least it shows there's 3 of them. One from each side and one from the bottom. So I just took these out of the South Bend lathe out in the garage. They're also using a dog point here. I don't know if that's necessary, but I'm going to set this up. I've already laid it out. I'm going to set it up and drill and tap those holes in the milling machine rather than the drill press. Okay, the work is mounted vertically, and I've already located using an edge finder. That would have been a 1/4 inch in this way and 2.5 inches from this end. So I will spot it with that spotting drill, which is about 1/4 inch, and then I'm going in with one size under 5/16, and this is a 5/16 reamer. I like the stubby ones. You don't have to drop your milling machine table so terribly far. And then 3/8/16 for this set screw. I will have to make new ones of these because these are way too long. That'll be an easy make though. I have marked all four corners at 45 degrees. That's about a 1/4 inch across the flats. It would look good with a radius as well, but I'm just going to knock those corners off. One more step. I have to drill 2 holes and tap them 5/16 18 for these 2 bolts. This is my 0 witness mark. I have it set at 0 here with my new little witness mark, which worked pretty slick, and I'll transfer these 2 holes and drill them and tap them off camera. I'm just about done. The last thing I need to do is to put the plug in here, and like I told you, it starts but it's tight, so I'm going to put this in the kitchen oven at 400 degrees for about a half hour and see if it'll pop right in, and then I will also decide whether or not I need to pin it as well to hold it in place. Okay, here it comes. It's 600 degrees. And this has been refrigerated. Wow, that plopped right in there. All right, I'll let that cool. I'm going by color here, which is about 600 degrees. So that should shrink on there. And FDR is helping me 70 years after he's dead. He is the spacer. Maybe you saw the dime. The distance that well, I'll flip it over and show you that when it cools. All right, it's cooling down, still a little bit warm. Now the purpose of that Roosevelt dime was just to space this, such that on this side I have a little bit of that diameter. Can you see that? And I did not want this side to extend up above. So, ready to assemble, I hope. So in review, it will assemble like that. And I have already made some more of these plugs with the 60-degree angle, and the longer one will go here where we have a little bit more distance, and the set screw, and then one of these, and one of these with the 2 set screws, and let's go see if it works. Now, since I did not use Loctite here, it's a press fit, I may or may not need to drill a hole all the way through and use a piece of 3/16 rod or something like that for a pin so it will never move. But I'm not sure that is necessary. I thought I was done and ready to demonstrate this and mount it on the South Bend lathe, but I ran into yet one more little problem, but it is easily surmounted. But when assembling here, I found that this plug protrudes, haven't used that word in a long time, protrudes just a little bit. So I'm going to mill some of this off, and I'm going to do that in extra credit because the video is so terribly long already. So watch for the extra credit at the end if you're interested on how I set this up and mill it off. So I'll see you then. I like this nut, how nicely it's crowned, and it's a finished nut on that side if you don't know what that is, but you know, there's certain beauty in that. They don't do that anymore. It's a weird size. That's 11/16, and I'll go ahead and tighten that on the 0 mark, and then there's also 2 bolts that go in here. And at long last, we're ready for assembly and testing. And there's that nice relief there. So I'll zero this up, but really I'm just eyeballing it here. There is no reference without doing some indicating, even though I have put a witness mark right here. Have to use that with a grain of salt. So I'll go ahead and tighten these two in that position. And now the milling attachment itself. And snug the bolts down. And it's about ready for some cutting. If you have forgotten what this attachment is all about, it gives me an extra 1.5 inches of travel. You recall in part 1, I didn't have the reach that I needed. Well, I got plenty of reach now. Now I tightened up the gibs to try to eliminate any backlash, and I will lock the carriage when I begin my cut, and I will take a light cut. It's a light machine, it's a light attachment, and I'm just going to go back and forth and square up the end of this 7/8 square piece. And at long last, here we go. Actually, too good to be true. Well, that concludes this rather lengthy two-part video. Make sure you watch both parts as well as my 1,300 other videos. I think the project was a success. Not that I will use this all that much because I have 3 milling machines, and this has, you know, value, but it's not heavy duty by any means, but this will improve its usability, I suppose, in the shop. So stick around for that extra credit and lots of still pictures, and I'll see you in the next video. Okay, this is extra credit as promised for those of you that can take a little extra punishment here. So I'm going to mill this off. So what I need to do is disassemble this. So that I can hold it in the milling machines, but first I'm going to determine how much I have to take off, and using a depth mic right across there, I have already determined that it protrudes by 24 thousandths, so that's, I'll mill off about 25 thousandths, then it'll be a little bit recessed. Take a look at the setup here on the Bridgeport. I put the larger vise on so I had a little greater depth here, because this is how I have to hold the workpiece. And I'm using a parallel up against this flat surface to force this surface up against the fixed jaw, and then this parallel here to set across this surface to make sure that it is parallel, and then I'll double check with an indicator. Okay, now the indicator already set up, last word, and I want to make sure this isn't cocked in either direction, although just a few thousandths wouldn't make any difference at all, but I want to make sure because I wear suspenders and a belt. You can't see what I'm doing here, or you can't see the face of the indicator, but it's at 0 right there, and I'll sweep across here, and it's within 1,000th, and then this way also I'm on 0 there and 0 there, so it's ready to mill. Okay, I just mounted a 3/4 cutter in the collet, and I'm touching off, locking the quill, backing off, and raising the table. I'll do it all in one cut. As I said earlier, 24 thousandths. You probably could not see that move, but I'm ready to mill. That's all there is to it, and I will chamfer just a little bit here all the way around while it's still in the vise. Then back over to the bench. Okay, let's see how it fits. Much better. As you can see, there's a couple thousandths difference there, so it is recessed now, and it will not cause any kind of interference. Now to mount this back on the other part, and I will pre-oil it. Well, that completes the extra credit. Thank you guys for the 4 of you that actually stayed with me.